A rectangular coil of 120 turns has dimension of 42 by 49 centimeter and is located in uniform 2 Tesla magnetic field. In 1.1 second, the plane of the coil is rotated from the position where it makes an angle 43 degree with the magnetic field to a position where it makes an angle of 60 degree. Calculate the average EMF induced in the coil. Okay, so since we have here theta 1 and theta 2, and this is the angle between plane and the magnetic field, okay? So don't be confused. So it's just a little bit tricky here. The first of all, what will be the formula of defining E average? Now, E average is equal, now you take the module, delta magnetic flux divided by delta T. Okay, now this magnetic flux by the formula is defined by the B area and number of turns and cosine theta. Okay, so that means you can say that here now this is a flux 2 minus flux 1 divided by delta T, or just make it delta T, okay? The flux 2 is equal to what? Is equal to the number of turns, B area cosine theta 2, and flux 1 is equal in BA cosine theta 1. Now, how can we find the theta? Since we know that the plane, this is our plane, now I'm just looking at from the side view, and magnetic field is basically this one. Okay, and the angle of the first case is theta 1. Okay, well, let's make it alpha 1. Okay, so the alpha 1 is basically, oh, let's make it theta, okay, since we have right in here theta 1. Okay, this is the plane, but however what we're looking for is that the angle between B field and area vector. Now area vector will be, this is our area vector, I call it n vector. Okay, that means you have to take the angle of between B and area vector, which is n. Okay, that means this theta 1 has to be equal to the 90 degree minus this theta 1, which is 43 degree. Okay, now then what happened after that? After that, the plane has been moved by 60 degree with respect to B. That means the plane, so this is a plane has been moved it, so that means this one is theta 2, right? So if that's the case, the theta 2, then we know that the area vector is in this one. Okay, that means we are looking for this theta angle. That means in the case of theta 2, the theta 2 has to be equal to the 90 degree minus 60 degree. Okay, that means we can see that this thing, the area, the rectangle loop has been tilted or moved it in the time of delta t, right? So delta t here is equal to the 1.1 second. That's it. So if you plug the numbers, you should get the answer.